On July 15th, a gigantic filament erupted on the Sun and dramatically reshaped part of its surface. In fact, the eruption was so powerful that it left a glowing trench on the Sun that was tens of thousands of kilometers deep and hundreds of thousands of kilometers long. Fascinatingly, the powerful spectacle was captured in all its glory by NASA's Solar Dynamics Observatory, which is why we know that it unleashed a coronal mass ejection. Today, we'll show you what's behind this solar monster explosion and what important new information it provides us about our powerful source of heat and life. So, be sure to stay tuned until the end to find out all the details of this exciting discovery. In our everyday perception, we often forget how small we really are. In fact, dramatic events occur on the Sun time and again that transform our blue planet into a tiny pinhead and impressively demonstrate the true proportions of our home system. On July 15th, NASA's Solar Dynamics Observatory, which has been studying our mother star since 2010, observed an unprecedented eruption that left a huge scar on the visible surface of the Sun. In detail, a huge filament broke off, creating a so-called canyon of fire that was an incredible 400,000 kilometers long. And just so we're clear, that's 15,000 kilometers longer than the average distance between Earth and the Moon. At the same time, the walls of the plasma-filled trench reached a height of 20,000 kilometers. And again, for comparison, the diameter of the Earth is only 12,742 kilometers. However, the brutal eruption did not simply fizzle out afterwards. It triggered a so-called coronal mass ejection, or CME for short. This term refers to solar eruptions in which plasma is released. This naturally raises a question of what exactly happened to our source of heat and life. To understand this, we need to take a look at the structure of our central star. As mentioned above, the eruption was directly linked to a filament. But what exactly is that? In simple terms, these are violent streams of matter on the Sun which are collectively referred to as prominences. And when these thread-like structures appear dark, experts refer to them as filaments. These structures, which can be several 100,000 kilometers long, can be observed in the Sun's atmosphere, more precisely, in the chromosphere and corona, and also occur in smaller dimensions within the solar disk. They consist of cooler, denser plasma that appears less bright than its surroundings and floats along magnetic field lines. This is no coincidence, as filaments always form in zones with strong magnetic fields where they carry the cool plasma above the Sun's surface and stabilize it there. Of course, the word cool is relative in this solar context. After all, solar filaments still reach temperatures of around 4,700 to 9,700 degrees Celsius. On the photosphere, or in other words, the visible surface of the Sun, the thermometer climbs to 5,500 degrees Celsius. But in the surrounding corona, temperatures of more than 1 million degrees C have been recorded. And against this heated and turbulent backdrop, it's hardly surprising that filaments are not made to last forever. On the contrary, after several days or weeks, they are already part of the cosmic past. Then they dissolve or are catapulted into space as filament eruptions, which is what the Solar Dynamics Observatory has discovered. However, solar filaments do not explode in the classic sense, but suddenly collapse and hurl plasma into space. And this is often very spectacular. When it comes to the question of why, experts point to magnetic instability, among other things. As mentioned above, filaments are held in place by magnetic fields that carry the cool plasma like arches or ropes above the Sun's surface. However, if these magnetic fields become too twisted, they lose their stability, just like a rubber band that is literally overstretched. In addition, in some cases, so-called magnetic reconnect ion occurs. This means that magnetic field lines break and reconnect, releasing enormous amounts of energy. As a result, the filament can be literally hurled upward. But sometimes the filament also rises slowly as the balance between the internal pressure and the external magnetic field changes. This continues until the magnetic structure finally collapses and the plasma of the filament is shot into space at high speed. With all this information in mind, We can now take a more detailed look at the exciting discovery made by the Solar Dynamics Observatory. In fact, this was not just any filament eruption. It was one of the most impressive eruptions of the current solar cycle. Basically, the solar cycle describes the approximately 11-year rhythm of solar activity, which is characterized by changes in the number of sunspots and the intensity of solar flares. And while our host star is currently in solar cycle 25, it's approaching its maximum, as evidenced by the latest incident documented in several international observation programs. The filament in question began to rise slowly on July 15th, providing scientists with a classic sign of increasing magnetic instability. As a result, experts expected an eruption to be imminent, and they were right. The magnetic field lines deformed and the tensions in the surrounding plasma increased before the magnetic structure holding the filament finally collapsed. And as the plasma then escaped into the outer atmosphere of the Sun at an insane speed, the eruption not only produced a coronal mass ejection, but also a colossal scar. As mentioned above, the Canyon of Fire was an incredible 400,000 kilometers long, and had walls of rising plasma that towered up to 20,000 kilometers high. But what does this actually mean for the future of the Sun? Will its face now be permanently scarred by the traces of this elemental event? Well, not quite. Detailed follow-up observations by the Solar Dynamics Observatory showed that the spectacular trench faded away within a few hours. Over time, the plasma cools down and the magnetic fields swirl around again, causing such structures to quickly diffuse back into surrounding area. However, the scientific value of this exciting discovery is much more long-lasting. This was initially due to the reassuring fact that the trajectory of the coronal mass ejection was not directed towards our home planet. If such a CME hits the Earth, it can have noticeable consequences. Depending on the strength, speed, and magnetic field direction of the CME, the effects range from spectacular natural phenomena such as auroras to serious disruptions to technical systems. Satellites, power grids, and radio communications are particularly vulnerable. And although the CME passed us by this time, minor changes in the interplanetary magnetic field were recorded. For example, the geomagnetic index rose to a value of around 5, indicating a weak to moderate geomagnetic storm. Such values can cause minor auroras to flare up in northern regions. But fortunately, they are not strong enough to have a negative impact on our satellites or power grids. However, the event had a positive impact on science. It's extremely rare for experts to observe such a large and clearly structured filament eruption in such detail. As a result, the spectacle on July 15 provides us with enormously important data about the mechanisms behind magnetic reconnect ion, the process by which magnetic field lines reconnect and release huge amounts of energy. In addition, the Canyon of Fire also shows firsthand how thermal energy is mobilized in such violent eruptions in the solar corona. No less remarkable was the timing of the eruption. It occurred in the middle of a phase of increasing solar activity which, as mentioned above, is heading toward the maximum of the current cycle. This maximum is expected between the end of this year and the beginning of next year. The incident is therefore also seen as a kind of harbinger because in the coming months we could be in for even more violent eruptions. The extent to which these will affect space weather and our technical infrastructure remains to be seen. And before that happens, scientists are trying to uncover as many details as possible about the current event. In addition to NASA and ESA, independent research institutes have also begun to evaluate the data. An initial simulation suggests that the magnetic field holding the filament has entered a state of torus instability. This is a form of magnetic instability in which the balance between the internal plasma pressure and the external magnetic forces suddenly collapses. Once this point is reached, the structure can no longer hold the plasma and it is released explosively. The bottom line is that the filament eruption on July 15th was a prime example of the dynamic, powerful processes that take place on the Sun every day. It impressively demonstrated how finely tuned magnetic equilibria can suddenly be thrown out of balance and what drastic changes this can mean for the Sun's surface and our home system. And even though this particular event posed no danger to us, it reminds us once again of the tremendous power inherent in our host star, and that we would be well advised to keep a close eye on our source of warmth and life. And now you'd be well advised to keep a close eye on your subscription. Just click the thumbs up and subscribe so you never miss another post from us. See you soon.